Good morning.
Good morning, Shri.
That okay?
Yeah,
Got a chance to work on that? What I said?
yeah, I did.
Okay. No challenges, right?
No,
Okay, cool. No holiday today?
we don't have a holiday here.
What? No. May Day is not a holiday.
I mean, in USA, we don't have any holidays.
Labor Day. Yeah, it's separate, right?
Yeah,
Mm. Yeah, I thought that May Day is a holiday. Okay. Hmm. Okay. So, hmm. Okay, she will join. Sometimes she will join late. So today, let us discuss about the PyCaret one. Okay.
sure.
Say when you talk about PyCaret, right? So this is also a library. Majorly, PyCaret is one of the low-code library. If
Hmm.
you might have seen till by now you understood, right? If you want to build any ML model, you need to write so much lines of code. Correct? The so many lines of code you have to write.
Yeah,
That too for multiple models, you need to write again. Every model will have certain group of lines, and if you number of models increases, your code will become lengthy. And again, the model training itself is not important. We need to even testing and then evaluation, and also we need to go and compare the models. Again, one more step is there. And then finally, ending up with the final model, which we need to again save it. So we need to import so many libraries here. Again, for saving the model, we discussed about a library called pickle library, right? We need to import it, install it, and then save it. And to load it again, I need to use load model. So there are so many libraries involved and so many lines of code involved. So the PyCaret, let me share my screen. So what is PyCaret and how it is going to like reduce the code and also increase the performance. So PyCaret is basically a low code ML library which was developed and which is a open source and which was developed to perform a auto ML. Auto ML means automating the complex and repetitive ML workflows from data preparation to till deployment. So by now you understood, right? That when we are building any ML models, we need to first collect the data before once we confirm this is the type of problem I'm solving. For example, either classification or regression, I need to go and collect the respective data related to model and then need to prepare that data by applying some data preparation methods. And after my data has been prepared, I need to go and bring that data into a form, and then I need to divide my data into training and testing again by splitting. For that, we will use a model selection module in scikit-learn, and which will help us to use train test split function to divide the data into training and testing. And after you divide, you will try to apply multiple models on the same data. And before applying also, you do some kind of scaling if required. Data scaling, data normalization, data binning. And to apply all this again, I may need to depend on other libraries and functions. And pandas will play a very important role here in the data preparation part. And after my model is, I'm trying with multiple models, and again I need to evaluate them. And each model will have a evaluation metric, and then need to compare all these models based on the evaluation metric, either accuracy or F1 score, or it can be regression, I go with RMSE comparison, and the least RMSE model will be considered as the best model. That this all will happen by a data scientist step by step manually. And finally, whatever the model we are okay, we will try to save that model into a model file, and that model file only we are going to use for the deployment. So till this, whatever I mentioned, all these steps we need to repeat multiple number of times with multiple experiments. That's what we saw even in the ML flow. And we even need to track the model file, the parameters, the metric, everything we need to again track. So for that, we need to use ML flow. I need to install again. So most of these things will give you, the code will be very lengthy, and again it will be high complexity to debug also. If an error will come, it is not easy, right? We saw even in some of the instances, the debugging is not easy when you build this many lines of code. So PyCaret will replace this lengthy hundreds of lines of code with few simple lines of code, and then it will speed up your development activity, and then mainly focus on the business outcome, not on the code or syntax errors. So to achieve this, we need to install the PyCaret library first. The import is need to be loaded, but before importing, I need to install the pip install PyCaret is required. As soon as you installed it, to start using it, you need to create or set up a PyCaret session, and data you need to also keep it ready. Whatever the data, it need not to be a prepared data. Even the raw data with the list of columns, and we should know which is the, it is a supervised learning, we should know the target variable, correct? No? Do you agree?
Yeah.
If it's a house price prediction, I know, okay, house price, I need to pass here, house price here in the target, and the data will become our data frame. So this particular function setup is going to start your PySpark session, and whatever the other, once you start this particular session, it will take care of data preparation like data cleaning, formatting, validation, and whatever required as part of like automated missing value imputation, typecasting, outlier handling, everything in this data preparation phase will be in this particular setup function will take care of. And any feature engineering required also, it will try to do, because it will generate the features, what features required. It will derive the features. If any features, additional features required by my model, because sometimes the existing columns may not be sufficient. We generate new columns also. Sometimes you remove the columns which are not needed. We can even clearly mention that there is a parameter to exclude the which columns not needed for my analysis, like ID columns. So which features are important, which features not important, the PyCaret will decide. So here if you see, square feet is there, price is there. By using these two, price per square feet will be generated. And that will be the new column. And once the feature engineering data preparation completed, my data will be ready. So I will go next level where my model selection and training should happen. When I say model selection, it is going to try, for example, it is a regression model. It will try with all regression related models, whatever available. It can be linear regression, lasso regression, ridge regression, elastic net regression, XGBoost regression, GBM. So there are so many regressions are there. PyCaret knows and it will try all those models by itself, and it will compare those models and select the best model, and even it will find out the best out of the list, the final one, and it will highlight on the metric wise which model is the topmost. A regression model need a list RMSE, so it will clearly display a table. So these are all the models and their RMSE, and it will highlight the topmost one. It is a classification. It will calculate the accuracy score, and it will create a table, and it will say these are all the list of models in the descending order of accuracy. So finally, we have functions available. Best model is a function. Compare models is a function. We just need to call, that's it. The setup, whatever is going to start, it will go and prepare the data, and it will try to initiate and bring the data. Once the setup is completed, it will clearly show us these are all the models, list of models, and it will try to show us. And when you say compare models, it will compare and show us. And if you say best model, it will go and give the best model and its parameters, everything. So the core benefits is here complexity. The model complexity will be reduced and speed up your ML model development. Correct, no? So I'm able to finish a ML model or ML project which I'm using thousands of lines of code. If I finish in 15 to 20 lines, it is saving so much amount of time, right? With best model selection. Do you agree? Both of you? I'll show you an example, then you'll come to know. So the objective here is to mainly it will find out the best model, and it will save your time to like 90% of your like time you do not even need to worry to prepare the data. The most of the data engineers, 80 to 90%, they will work on preparing the data only. Only the 10-20% only we go and build a model, train it and test it and evaluate and apply. So most of the like the effort will be automated. So we have what core ML module it is supporting. It is supporting all the classification regression models. These are the 4 functions. Can you see that? The first function need to start with is setup. Second function, compare models. And then we have tune model also. For example, I got one best model, but I want to further tune it. And tune model will try to change the parameters itself, but it will tune and it will give the best out of the model again. And if at all I want to like go and display the metrics in the form of a chart, what I need to do generally? I need to use matplotlib or Seaborn, right? Okay.
Yeah.
But here we do not need that. There is a plot model is there. A simple function. A plot model will plot your model metrics, the important features, everything will be ready. And this is about classification or regression. But coming to under supervised learning, in unsupervised learning again, we have clustering and then associational mining and anomaly detection. These are all fall under unsupervised learning. So clustering, for example, so we know clustering, right? We do not need to go and predict anything. We just create some groups or clusters. Anomaly detection means you go and find out anomalies in the data. Maybe I have hundreds of transactions. Need to find out which are the suspicious. Then anomaly detection can help us. That is also one type of model. So here the functions which clustering and this anomaly detection is providing are setup function is same, but create model, assign model, predict model. These are all will help you to build a unsupervised learning model also. So the workflow, how we will need to start with is start setting up the session, and it will go and take care of every step that required for your pre-processing, and then call compare models, and then find out which is the best model out of the list, and if needed you can tune the model also, and then we can even optimize the model, blend the model. So all we can do as part of tuning, and finally model analysis also I can do to see the model performance. Plot model and interpret model, there are two functions which this particular PyCaret is a library, so it contains so many functions, and whatever the model I finally decided, I can even integrate with MLflow also. There is a option to log your model metrics. There is a log model also is there. I do not even need to install MLflow, all this stuff. Simply add a parameter in the setup function to log the model parameters and metrics. So it will take care of. As soon as my model is ready, final model, I can say finalize model, and then we can even save that model also. See, all these are functions. Did you observe that? Did you
Yeah.
observe that? Everything is a function here. Nothing to do. Nothing to do from our side. Just call the function at the right function at right time. Clear? So set up the processing, which will go at maximum, not even 50 lines. I saw many times. It maximum 30 to 40, maximum 50 lines. And once you decide this is the data target column, then call compare model for selecting the best model. And whatever the model you got the best model, you can simply pass that model to tune model function. It will optimize the model and it will tune the model. And sometimes you will try to compare the models by using a stacking method also. Stacking means you will go and verify which is the best out of the list. So for that we can use the blend model function also. It will give these are all the models, top 10 models by this particular criteria. So we'll see some examples, then we'll understand better. So assume that I have some house pricing data which will have like I want to go and predict the house price. When I talk about predicting the house price, what is the type of problem? If I ask you, is it classification or regression? Who will tell? If it is a house price prediction I am doing, my requirement is to predict the price. And what will be the type of problem? Is it a classification, or are we classifying, or we are trying to predict some value, numerical continuous variable? Here we are doing
If it's a constraint, then it is regression.
regression. Correct, you're right. So we know that now this is supervised learning, correct? No, the first thing. And in
Yeah.
supervised learning, we need to find out which is the independent and which is dependent and which are the independent variables. Here we clearly know that our use case is house price prediction. So we need to predict the house price. So we have a house price column. So we consider this as a target column, correct? No, and these are all the factors, right? Out of all these factors, every factor will impact the price, correct or not? Square footage will impact house price. Do you agree?
Yeah.
Number of bedrooms will impact. Number of bathrooms will impact. Year built, when the house was built, that also will impact, right? And
Yeah.
the size in acres. So garage size, people look for neighborhood type. All this will definitely impact this price. So I need to pass this data set, whatever we are just generating here with this house price values, whatever we is having, we are going to pass this data by converting into a data frame. We will try to pass this particular data as well as, and we'll clearly mention that price is my target column. So while starting the PyCaret session, will inform PyCaret that this is the target column, target equal to price, and we simply pass this data set to the PyCaret. That's what we have to do. First, let me import this. So it imported pandas first, and then it loaded my data, and it converted my CSV file into a pandas data frame with name data set now. And we will try to, even I can split the data by using a function called sample. So this particular data, 90% data I want to use for my training, and 10% I want to use it for later evaluation. Just like I want some new data. So as soon as my model is ready, final model, I want to use it for prediction and evaluate it on my own. So I'm just keeping the data aside. So here the sample 90% will become the training data. Remain 10%, I'll call it as a unseen data, so that this will 10% I'll use later. And we go and divide how many like records out of maybe total 1000 records are there. 900 will come to normal data. 100 records will come to this one. Because this you can say normally any ML model, right? General people go with training and testing only. But in some of the projects, people use training, testing, and finally evaluation also. For evaluation also, they will keep some data. You are getting right? Not only for just training and testing. So out of my entire data, some teams will divide into three parts. First for training, and then testing, and then evaluation. This evaluation, we can consider that as a new data, which my model does not even use that data. So here data unseen, I am considering as a new data. So I am going to pass this data to my model as a new data after model is created. So let me try to see, this is my actual data. I am going to use this particular 900 records. Again, I will divide them into training and testing and use for model. Finally, once after my model is ready, I'll pass this 100 records and I'll verify how good my model is. This is for my understanding, my requirement here to test, or we can say evaluate after model is ready. So before that, I need to initialize PyCaret. How to initialize? I need to load the regression, PyCaret regression module. Import star means it will import all the functions of regression. If I say classification here, it will upload all classification. If it's a clustering means it will import all clustering functions. Star means. So assume that it executed, and I am going to call the setup function where my data is nothing but the data frame of 900 records. Can you see this? I am clearly mentioning as price here, my target. Did you observe that, both of you?
Yeah.
I clearly need to mention which is my target. According to the target, it is, for example, my target, it will go and verify PyCaret library. If it is numerical continuous column, then it will decide it is a regression by itself. If, for example, my target column, what I passed here is a categorical, it will automatically use the classification algorithms. I do not need to inform PyCaret. Go and use regression models. Go and use classification models. Whatever the target column I am passing, it will verify the type of data, and according to the type of data, it will decide, which is good also. I don't need to take any decision here. So I am giving the decision to, giving a choice to PyCaret to take a decision. When I pass this price column, we know that the numerical column. So some people even does not know which algorithm to try. So when they pass this as my target column as price, PyCaret will understand, okay, its price is according to the data, It is a numerical continuous variable. So let us try the regression model, whatever we are going to try. Normalize true. So perform a data normalization wherever required if my any column is not a norm following a normal distribution. Transformation true means it will apply the transformations on the data. It can be a logarithmic transformation or a like a numerical transformation. It will apply on the data to keep all data in the single scaling. And some columns we do not require in the model. If any column you feel that that is not important to the model and which you don't want to include that in the model training and testing and evaluation and all, you will add ignore features column also, parameter also. Like our git ignore file. What git ignore will do?
It
If
will
I,
ignore files.
it will ignore the file when I add to that file, right?
Yeah.
Similar to that, this ignore features will exclude these columns in the training. Don't even touch these columns. I can add multiple columns also by comma. If I feel this column is not important, it is not going to impact my model or my house price, I will ignore this because that is not required. Okay. So let me try to start it. So what it is doing, it is starting a session here. If you observe here, and target column is price. See, it is automatically identifying the regression. Can you see that? When I run this, I am not telling that this is a regression problem also. I hope you are following what I am trying to say. Based on the type of target I am passing, it is automatically identifying this is a regression problem. Plus, it will go and now try with the configured PyCaret configured regression models now one by one. See, now it will go and it already performed. If you see here, out of my 900 records of 8 columns, after transformation, the 8 columns converted to 10 columns. And it took the transformed data training and testing also. Can you see that? It divided already. One feature it ignored, which we already added here, this one. And after that, how many numerical features, how many categorical it is showing. We know, right? How many numerical, how many categorical you can see here, right? One categorical is there, neighborhood type. Correct or not? Rest all are numerical, right? Whatever. Yes or no?
Yeah.
It is identifying all those. If you observe here, it is trying to figure out how many numerical, how many categorical, what is the method to replace missing values. It is using a mean imputation, average imputation. All these by default, PyCaret is deciding. We can even change all these parameters also. We can override if needed. If you know, and if you want to add any your own imputation method, there are some parameters which we can change. And finally, like it is going to like a log experiment. It is showing as false. If I give log experiment to true, I can integrate ML flow. If at all I want to integrate ML flow with PyCaret, this should be true. Are you getting? We use ML flow also, right? In the previous class.
Yes.
So if at all I want to integrate that ML flow to this PyCaret library, I need to just enable this property to true. It will log the parameters, the metrics, and then the model, everything it will track when you enable this property. But default is false. But as of now, I do not want to track. So I kept it as default only. So whatever this you see, most of the parameters it will use on its own, it will select. The default, the best values only it will select. So after this particular pre-processing is completed, now I'll simply call a function called compare models. I'll say best model equal to compare models. So when I run this, PyCaret will try multiple regression models and it will try to sort those models in the descending or ascending order of RMSE or descending order of R square. So if you observe here, I'm just trying to run this. Now it started trying. If you observe here. Now it started trying. It will try every model one by one. You just observe this. It will still show every one model, and it will try to see it started. See, it is trying one by one. Can you see that here? Bayesian ridge, passive aggressive regressor. These are all the different regression models. K-neighbors regressor, random forest regressor, destinatory regressor, extra trees regressor is there, ADA boost is there, grade boosting is there, extreme grade boosting is there. These are all, see, light gradient boosting machine is there, correct? Even I don't know many things, huh? I know linear regression, lasso, ridge, and elastic net, only four, and a polynomial. But we do not need to remember this many regressions because PyCaret is doing that. I'm just telling you the author, he include all this. Who invented this? To try all this. So whoever invented PyCaret, he include all these different regression algorithms. So here, if you observe here, the best model it tried. Display. Best model. So it took cat boost as like my best model, but let us try to run this separately. Now it will show one by one. Can you see that? It is showing here, both of you. It is showing one by one. Can you see that?
Yeah.
It is trying now. Again, I'm just running that. And finally, it will automatically sort also. So it will show in the order of R square, in the descending order of R square, which is in the ascending order of RMSE, MAE. We call it as mean absolute error. So is 88% completed. See 98%. So the cat boost regressor is the one which it selected in the top if you observe here. Can you see that? Because that is having the 94% accuracy you can consider. So which is having the highest R square, you have to consider that in the regression models. Even I have not selected, correct? No? PyCaret selected this by comparing, by applying them to my data which I passed. So this R square, which is the cat boost. So when I say best model equal to this one, that's what it did. When I say best model equal to compare models, it gave the cat boost only. Can you see that? This one, correct? No? Because it is having the highest R square. So now I need to use this model and I can even tune this model also. So I can go and use this and I can go and even apply tune model of I say best model. My best model is nothing but this one. I'll say so it's a cat boost. I'm just creating a because cat boost was the model which PyCaret selected, I'm just using the cat boost only as per my current data. So it will clearly show us. So cat boost has been created. Let me run this, and this is the one, and I'll say tune model of cat boost. I'll say the tuned cat boost. This is going to find out the best possible parameters, and it will, as of now, what is the percentage of R square we got? 94.47 you can consider. So after tuning the model, it may increase also. Let us try to see that. The tune model will try to optimize your model. Let me try that. So it is searching for hyperparameters of cat boost automatically, categorical boost, and it will try to use a method called k-fold cross validation in the background, and it is trying to optimize this cat boost model what I created. This 94.47 may go up if this particular tune model is going to tune it. See, to achieve this, again, I need to add some hyperparameters and I need to call, right? There are some parameters which you need to consider when you are tuning your model. You need to remember all those in general traditional approach. But here, I'm simply calling the tune model function. That's it. So it is trying in the background. See, 43% completed. It is using a tenfold cross validation. Finalize the model. So it is finalizing the model. This 94.47. Let us see whether it increased or is there an improvement or not. A little bit increased. Can you see that? 94.47. It increased 94.87, right? Both of you? Did you observe that? The improvement? 94.47. But here, what is the value? 94.87, which means that it increased a bit, right? 0.4 it increased. So even it is a 0.4 or 0.1, if you improve your model, that is good. So when tuning the model, it will try to help in optimizing your model. So the tuned cat boost is my model which I tuned. I'll pass that particular tuned model to a one more function called plot model. So plot model will try to plot the tuned model like this. So to try to show. So before finalize my model, I need to evaluate my model to see what is the prediction error, feature importance, and all we can see. So the R square, it is for training, it is giving 97%. For testing, it is showing as 94.3, something like that. So we can also see the prediction error also. Let us try to see how much error, because 94.87 means the remaining 5.13 something is the prediction error. So this is the normally to plot this particular like the regression model, we will use some functions in the matplotlib. But here simply we are calling plot model function with some parameter. So this is clearly showing the best fit line is the black dotted line. That is what the model predicted. The actual one is the gray one. So the model predicted is and the actually are not that much like different. So both are a little bit nearby only. So the prediction error is not that much. That is the reason. So the prediction error is only 0.94% means only 6% something only the error out of 100. And feature importance also you have to see. So which features are giving more weightage to the model, that also you have to see. See, out of my all independent variable, you can see here, the square footage is giving more weightage in the prediction, followed by neighborhood type luxury, neighborhood type rural, you can see here. So which factor is impacting? What you are able to see here, which factor is impacting my house price? Square footage will impact, right? Sometimes. Do you agree? Both of you?
Yeah.
Purnia, square footage will impact, right? The price.
Yeah.
And also neighborhood also people will nowadays considering, right? The luxury people
Yes.
not be ready for urban urban area or I mean rural area and all, right? Generally people they need a
Mhm.
luxury kind of some neighbors. It happens. But some people want to be like a silent, peaceful area, so they go with some village atmosphere and all also outskirts. People are there in different mindset. That depends again. And number of bedrooms also, year built also, number of bathrooms also, all these are factors. So we can give a insight that the square footage where the most people are interested. That is where house price is impacting more. And you can tell the client that these are the different factors that impacting in this order. So need to focus on these top factors. Maybe this first four or first five you need to focus more while talking to the customers because they are impacting much. So evaluate model. So it will go and provide multiple plots here. We can go and like click and see. So pipeline plot is the one hyperparameters. It will show which are the best parameters for my cat boost. These are all the parameters. So I can go and verify like a prediction error. Everything is in one place. Feature selection. And we saw say feature importance also. So all this will come in one particular like evaluate model output. So now if we go down, so we can also use the predict model also. So the predict model will automatically use my testing data and it will go and the data and it will go and give the 30%. Think it is running. It has to change the model name also. Yeah, something. Is there any scenario where the PyCaret now and what are the challenges? Uh, the first question answer, if you, your company or bank is not ready to use third-party libraries, you need to you need to see that because not everyone will be ready, right? And
Okay.
the company, if a company is liberal and the IT support is liberal, nobody is like opposing to use it. It'll be easy, right? Sometimes what happens, you'll have some restrictions to install third-party libraries also. The first thing you have to go and check it first. You need to tell them, you need to justify them how it is helping you, and you need to showcase that it is saving your time also. Correct? No?
Okay,
That
but
is,
if there is any bug, it is more difficult since we are writing in
no.
algorithms. It will be
Uh-huh.
easy where it is throwing an error. Since it
Uh-huh.
is
Uh-huh.
automated, we really do not find it easy in order to solve the problem, is what I felt, but I'm not sure in real time scenario.
Out of my experience, most of the cases, 90% or 95%, I was able to resolve.
Okay,
The issues are not that much complex. Most of the things will be data issues. The syntax errors, you can't find that much syntax error because most of the code is very limited, right? First thing, you need to use the right parameters and right function with the right data. When the debugging come into place, so debugging is not that much difficult, which I feel, because most of the code is coming up with the functions only. That is where in my experience of this 3 to 4 years where I'm using this, I never come across any complex and roadblocks also, because the particular community also who is working on this is very very active. Are there any known errors? They are posting the resolutions also in the GitHub. You can go and check it immediately.
okay,
The functionality wise, whatever the limitations, they are clearly indicating. So if you find that those limitations are okay, you can use it. Correct, no?
okay.
Yeah. And second thing you are asking, how do we know if it is a underfitting or overfitting? This generally underfitting or overfitting. This will come into picture when your model is giving very good results for the training, and when your testing is not giving the same results, that is overfitting. If the testing data is giving very good results and the training is not coming up to the mark, that is underfitting. So that we can see by looking at the metric only. The metric r square, for example, it is giving 94% for my training, and for testing it may give 91%. So that is not correct, no? It should be at least nearby. So sometimes you will find your model for any kind of data, it will be giving the same 91% only, even if you change the data. In that scenario, there might be the possibility the model is biased to do some kind of data, that is overfitting. And the
Okay.
third one you're asking, can we use test size instead of parameter from 0. So test size, you will you're asking about the function, time test
Yes,
split?
on the top, we passed a parameter saying that
Uh,
instead of test size, we usually do that, right? Test size equal to 0.8, 80%.
That time I usually in the train test split you have test size and train size. That's what I think you're talking about, right?
Yeah, yeah,
So
that's what
here, just let me check it.
Here, frac equal to.
Frac equal to this is nothing but this is not a PyCaret function. You can use train testers also. Yes, correct. That this is sample function, right? This is a statistical function I'm using here. In this place, you can use the train test size function also. I mean, train test split function. You can use it. It's okay. But the requirement here is you need to divide not only train test split will divide your data into training and testing. Correct? No, generally. But
Here
here
also it is dividing into
three
sample.
parts. But here we are dividing into three parts now, not two parts. This is the whole training data. I'm just sampling only. I'm using here. I'm not using train test split here. See, sampling means what? Sampling means I'll use a sample of 90% of the records out of my data, and I use that for out of entire data, this 90% what I'm using. This one I use for training and testing. Are you getting? This 10%, whatever I'm going to use, that is for, I will use for final one more time for evaluation, second time evaluation. See, testing itself is evaluation, correct? No? Do you agree?
Yeah.
Testing itself is one method of evaluation. This unseen data is the second level of evaluation some people use. So what some projects will use, they use training data, testing data, and also evaluate data also. Evaluated data, three types. Not only training and testing. We discussed only training and testing, right? We never discussed about a separate one more type, evaluate data also. So that also some projects will use. So here PyCaret already using time like this particular, it is dividing already. Can you see that? Out of my 900 records, it already dividing training and testing. Can you see that? 630 and 270. Can you see that?
Yeah.
But this is actual training and testing. But initially, whatever you are doing, that is basically I want to keep some data which my model should not touch. So I want to keep that data. For further, I want to finally evaluate once before deploying my model. So that I can see that how my model will behave for any data which it does not saw over the training. That will give you some more clarity, more better results if you try or test with a data which my model never saw. That is called unseen data in some terminology. So my 1000 records, I am dividing into total three parts. The first part is like 630, second part is 270, the remaining 100 one more time for the same I will go and use for the predictions. This is for predictions only, right? This 270, correct or not? Do you agree? So my testing means what? I will use for prediction only, right?
Yeah.
So for one more time I use for prediction. That is what this 100. This 100 records. Unseen data for predictions. Either you try, you can, that's up to us whether you use it or not. But you can directly use 1,000 here. You do not even need to use this one. Just directly pass data here. That's also okay. Without dividing like this also you can pass. Then what will happen? This will be 1,000 records will use. Correct, no?
Yeah.
So you can try like that also. You can see whether how it is giving the performance also. Clear?
So it can do EDA as well.
EDA, that's what it is doing, right? Exploratory data analysis, whatever you see.
And feature engineering
It
as
is
well.
doing already. It is
Multiple.
already performing, selecting the features, right? It is creating feature importance, feature selection, and it is generating some features also. If you observe here, there are some new features got created. Let me show you what features it created also. So it is not showing, but the feature selection you can see. Square footage out of this data, because the actual number of features are like somewhere it was showing total how many features are there. 1 2 3 4 5 6 7 and 8 features are there. One is independent, seven are sorry, one is dependent and seven are independent, correct? No, correct or not?
Yeah.
But here if you see that the original data shape 900 records and 8 columns, correct? No, one house price, one dependent, remaining 7 independent, correct? No, but after transformed the data shape, how many are there? Can you see that? 10, right? 8 became 10 means it did some feature engineering, right?
It has to be 9, right?
No, total 8 only. One independent house price, remaining 7 dependent. If you see here,
Oh, there are, okay.
only 8 only here. Out of 7, out of total 8, it became 10 because there is one extra variable it created. Are you getting? Excluding a dependent, 10 means here one dependent you can ignore. That is house price. And remaining 9 only, right? 10 means, do you agree?
Okay.
So which
So
means that, huh,
is there any command that we can see what it's hiding and what it is not? I mean, what it is considering and what it is not considering, like in the features?
features we already
Everything is
we already
automated and
added. No, we already added which features to exclude here. Ignore features. See, lot size acres, which is one of the feature out of my columns. This one we already excluded. Correct, no?
but we can, I mean, it is not mandatory to mention as per your
Correct. It
estimation,
is not
right?
mandatory. It is not mandatory. But here it will clearly show us which features and how many features are there, how many numerical, how many like categorical, all it will show. But I need to figure out what your question. You're asking like
Yeah.
which features it created and which it removed. All this you're asking, right?
Yes. Since
I
I'm a beginner, if I don't want to mention any of those and just
correct.
give the
Agree.
independent dependent variable, I would like to know what is exactly going on
Correct.
behind the. So
True.
I just,
But that that I you need to go and look at the like PyCaret documentation because these functions only majorly will give the visibility, but rest all the what this function is PyCaret is doing in the background. You need to check the documentation. Even I need to check that once because the first time I got a question from you about that. So how it is doing in the background and all that because every algorithm will have its own way. Correct, no? But, but the mathematics behind that we will try to understand. But how PyCaret is doing, I never did any background check, but I need to do that now since you asked me. Okay?
okay.
Yeah. But you understood, right? See, most of the lines of code, if you see, it's not even 20 lines, correct or not? Do you agree? Both of you?
Yeah.
It is not even 20 lines, right? Not even 20 lines. You can observe. Whatever the code we have written in earlier also is very lengthy. Very lengthy, and within 20 lines we finished everything. The final model also, plot model we did, evaluate model and predict model and final model. See, finalize the model. So I'll go and use I'm considering the cat boost tuned one is my final one. So I'll say this is my final model. So this is going to give me the final model is this one and its parameters, everything. So I can even pass my final model here is my unseen data, which I separated 100 records, and I can predict and I can see what is my actual and predicted also here. You see here, this is the actual price and this is the predicted price. Can you see that? For my 100 records which I passed, this is the actual price and this is what this model predicted. Can you see that? This is what we interested, right? We are interested, right? Correct or not? As per my data, how much price my model has to predict. This is what generally people are interested. And the difference will be the prediction error. But we can see most of the like difference is not that much. So my model is 94% giving accuracy means it is doing good job only. So 96%, I mean. So 4% only it is not doing like even the like good results. So that is the reason you can see the values also almost nearby. So saving the model. So final model to save. See, I'm not even telling PyCaret to save in pickle format. By default, my model which I decided, this final tuned cat boost model, I'm just calling a save model function, and this model will be saved in my current folder if I run this. Can you see that? Yes or no?
Yeah, what is it saving as? Dot pickle or?
That pickle only default. See, we have not even imported any pickle library also, correct or not?
Okay.
So the PyCaret, the library knows it has to save it in pickle format by default, and it is doing that. Clear?
And where is the evaluation step?
Evaluation step is this one only, right? The prediction.
So is it considering it as a test or
No, unseen data.
evaluation?
Unseen data, right? 100 records. Out of my 1000 records, for example, we separated, if you remember, the first step we
Yes, we
separated.
separated, but you said there are three steps, right?
Huh,
Test and evaluation,
correct,
but
correct.
I
Testing it
couldn't.
will do automatically. It will do automatically, and we do not need to go and test it. So after testing only, it gave us the final model and best model also, right? By comparing. This one, how we got generally R square. After you go and train it and test it, and you see the difference between the test data and the actual data, then you will get the accuracy score, right? Correct or
Yeah,
not?
but this is only on a 900 records. It doesn't apply on the other unseen data, right?
Correct, correct. Then you have to manually do that. See, whatever you did the 100 records, then you need to see the difference here, right? That is what it is showing already. You see, this is the tuned model. This already giving us, this is the R square. But if you see the predict model, it is showing us the unseen data. It is showing us here whatever is nothing but this is the, not this one. Here. This is the difference between this value only will become my error, right? R square 96%. It is showing already here. This is what the model already giving us, 96% on average. See, generally we separately go and calculate all these only, but here the PyCaret is already doing that. We do not need to do anything. Whatever it generated, you need to just cross check, because even whatever you do in finally evaluating the model, what in the evaluation, what you do generally, if I ask you?
We just check whether it is
Huh, huh.
generating what we expect or not.
That is always showing here, right? Yes or no? See,
Okay.
by looking at this, I can conclude that the difference is whatever. By looking at this data, I can confirm it is giving better results only, right? Also, it is showing me 96% is the accuracy score. This is what we need, right? This one and this value. For this
So
only we'll try,
there
we
is
use
no
functions
other
and everything.
extra step.
Huh?
Sorry. So there is no other extra step to in order to
No,
evaluate.
nothing we have to do. See, this is generally, that is what auto ML means. Auto ML means we do not need to go and again perform any evaluation from our side. Just feeding your data to a tool. The tool will take care of everything. That's what happening here. Even in our goal is here to get the final best model. Correct or not? Do you agree? That's what we are already getting, right? Are you able to understand what I'm trying to say?
Yeah, it's kind of everything is automated. So I was not
You're asking
understanding
you
what
asked
is
the same
the.
question yesterday also. What we have to do? See, what we have to do means we have to compare and check this. The
Okay.
market is
So
like that only. No, the market is like that only. That's what I'm
okay.
saying. See, if you want to do on your own, you need to put so much effort, and it will be time consuming, right? Correct or not?
Okay.
As per current market, I'm talking about. If in my case, when I started data science and all ML, all this, that time that is really required. But nowadays, nobody is looking for to manually do all this. Some companies are not even using even PyCaret also. They are using some Copilot, other tools. Simply go, they will go and pass the data, and the tool will give the results. Final model also. See, you just need some knowledge to evaluate what this is generating. Correct? No, you are at the stage now. Further, it will further go on next level also. This is very basic. What you are able to see now. To go to next level, you just feed the data. That's it. You will ask, give me the best model. That's it. In English sentence, it will give everything, code and test cases, everything. Already, it is running in the market now. It's all Copilot. Okay, learning purpose, you can do many things. Huh?
Okay.
Are you getting? If you go to production environment, when you are doing these kind of activities, nowadays the clients are not like earlier. They want everything instant. Correct? No?
Mm-hmm.
Immediately they want. Immediate they want self-service models also. What is a self-service model? Model as a service. They will feed the data on fly. They'll click a button. It has to find out the best model by like this, and they will again need to pass new data, and that model has to give them what they're looking for. Are you getting what I'm trying to say?
Kind of.
So now model as a service running now. Seriously, I'm not joking. The models became now generic also. I create one model and that just changing the parameters, the model again will change its behavior also. One model, same model. I built one generic model for supply chain also in 2017. So because every team wants to use one model and they want to change the parameters. They don't want multiple models also. So now it is ML ops is also crossed. Now it is going with model ops. The next level. So you heard about data center. Huh?
Yeah.
So now there is a model center also. A
Okay.
model center contains all the enterprise level models. So anybody can go into model center. They can go and collect whatever the models they want, and they can feed their data, and they can test it, and they can generate some predictions, and they can use it. So
Okay.
the are you understand? I will understand.
Yeah.
That is now the market is running. The artificial intelligence and then generative AI also now people are everybody know in the market. So now next level is also coming, which is called super intelligence now. The next level. The AI is now going to SI. Super intelligence. This is the next level with quantum computing and all this stuff. So which is within milliseconds your model will be ready. Just to feed the data, click a button, you will see the result on fly. 20 years data within 2 milliseconds it will process. I visited last week the Netherlands, one company. They are using the quantum computing already. They are using very high-end infrastructure. They are processing 30 years data within, I think, almost 30 years data within 4 seconds or 5 seconds. You can imagine how much amount of data for 30 years and how much infrastructure they are using. Are you getting?
Yeah.
So we need to run with the tools and You are learning, that's good. Learning the model and what is it is doing and what is the terminology and all, but at the same time, try to find this kind of automation tools and then reduce the code. So reducing the code will reduce your errors and debug time also. Correct, no?
Okay.
Yeah. Okay. I'll share this script and a PPT is there. Just go through that PPT also, two PPTs, and try to work on this. Okay.
Yeah. Yeah. Thanks.
Okay. In the next class, I'll try to show this classification, one more classification and one more clustering algorithms also. And you can also look into that within PyCaret. Okay.
Okay.
Okay then. Yeah. Thank you.